let's look at the daily challenge problem. Problem 215. So kth largest element in an array. So this is a sort of a small problem, but maybe it's interesting to look at the heap implementation in Python for this problem. So I'll quickly read through the statement of the problem and then give a solution using the heap. So the problem says that given an integer array called nums and an integer key, so we return the kth largest element in the array. So notice that it's the kth largest element in the sorted order, not the kth distinct element. So here is an example. So the second largest one is 5, right? In this one, the fourth largest one will be 4, because the previous three are 5, 5, 6, so that's 4. So here the constraint is that the k is greater or equal than 1, less or equal than the length of nums, which can be 10 to the power out of 4. So the second constraint is about the range of generic element in nums. So with that said, let's look at the procedure. So this is a very straightforward problem. So here we want to see, let's try to avoid using sort and slicing or directly call n largest function in heap. So here the method we're going to use is heap, and we're using the min heap here. And the procedure is as follows. So we initialize a heap, and our purpose is to maintain a heap of length at most k. So then we traverse the nums array. So if length of the heap is less than k, we just push the num into the heap. Otherwise, we push the num into the heap and pop the smallest element in the heap. So in other words, we keep the heap length at most k. So here is a quick example that I cooked just to mimic the process with minimal effort. So here we have 3 elements, 3, 2, 6. We want to find the second largest one, that is 3. So in step 0, so we put this number into the heap, that is heap equals 3. The length is 1. Then in second step, we put 2 in the heap, because now the heap length is 2. Previously it's less than 2. So in step 3, in other words, I equals 2. So we found that the heap length is already 2. So we first push the number we are looking at, that is 6, into the heap, and then we do the pop. So we pop the 2. So what we get is the 3, 6 actually. So finally we return the heap pop, in other words 3. So that's the whole procedure. So it's sort of straightforward, but it's good to look at the heapq module through this example. For this purpose, I will directly write the code, import heapq, and then basically we want to do the above procedure. First, let's initialize a heap. So let's just use an empty list, and then we do a count. The count is how many elements currently in the heap. Then we iterate in nums. Then we're checking if the count is less than k, right? If this less than k, we are going to push the current element to the heap, that is heap num, and then we increment the count by 1. So this is the case. So sorry, I'm missing the if. So otherwise, what we do is that we push and pop. So heap q, heap push and pop. So do it in one go. So this is the heap. We want to push the nums into it and pop an element. So finally, we are going to return heap q, heap pop. What we want to pop is from the heap this a heap named HQ. So that's about it. So let's test the generic case at the very beginning. So yeah, let's pass the generic case. So the time complexity and space complexity is actually very easy to analyze for this problem. So we do this in a linear fashion. This is a for loop, so n times. So each time we basically push or pop. So push or pop is a log length operation. So basically we have the nums, so the length of nums times the push and pop operation time, that is logarithm of the length of the heap, that is at most k. So that's it. That's the space. This is the time complexity. Space complexity is bounded by k in this case. So that's about it for this problem. Thank you very much.